So this time we're asked to solve the following systems of equations graphically. As I had mentioned earlier, we always want to have our equations in the form y equals. This allows us to plug our equation into our calculator and find our intersection points. So for this first equation, we see that adding y to both sides will leave us with x plus 1 equals y. And with that second equation, we could subtract y from each side and end up with x squared minus 6x plus 3 equals negative y. Now it's not great to leave our y in the negative format, so let's multiply both sides by negative 1, which leaves us with negative x squared plus 6x minus 3. Again, that negative 1 has to come into every single part of our equation, and that gets us our positive y. So we're going to go ahead and show you how to do this on our TI-83 or 84 calculators, if you want to follow along with that. Awesome. So we have our TI-84 calculator here. It'll be a very similar process to your TI-83. So we start off by hitting our y equals. We're going to plug in our equations there. So we have x plus 1 in y1, and then we have y2 equals to negative x squared plus 6x minus 3. We're going to go ahead and hit graph. There we see our equations. So again, we want to find our intersection points. What we do is hit second function, calc. We're going to go down till we get intersect. So notice we see this is first curve. Okay, so we're on our first line. We're going to hit enter. Second curve, now we're on our parabola. We're going to hit enter. It's going to say guess. We're going to hit enter one more time. And we see that our intersection point is at 1, 2. So x1, y2 is a solution. We have this other intersection point up here, so we're going to find the solution for that. So again, second trace, intersect. Now I want to move over closer to that solution, then hit enter. Okay, second curve, enter, enter, and now we find 4, 5. So our solutions for this system of equations then is 1, 2, and 4, 5. So let's go ahead and write those solutions down. So we have 1, 2, and 4, 5. Okay, like we said earlier, these solutions should work for our equations. Okay, so I should be able to sub 1 in for my x and get 2 as my y in both equations. Likewise with the 4 and the 5. So when I ask you to verify your solution, we want to do this for all solutions in all equations. Okay, so we're going to start off with y equals x plus 1. So I'm going to plug in my 2 for my y and my 1 for my x. We end up getting 2 equals 2, which is a correct statement, so we're good. Then we do it with the next one. So again, we have x plus 1 equals y. I'm going to plug in my 4 for my x and my 5 for my y. I get 5 equals 5. We're good. Let's move to our other equation. We have y equals negative x squared plus 6x minus 3. Again, plugging in both solutions. So we'll start off with our solution 1, 2. Negative 1 squared. Okay, here we get negative 1 squared, so a positive 1, and then that negative in front, so negative 1 plus 6 minus 3. We have a negative 4 and a plus 6, so we end up with 2 equals 2. That one's good. And lastly, again, y equals negative x squared plus 6x minus 3. So I plug in my 5 for my y and my 4 for my x. Notice that 4 went in the brackets, not with the negative. That's important not to make that mistake. we end up with 5 equals, this is 4 squared, so 16, but then we have that negative plus 6. Oh, I missed that 4 before. We'll get that in there now. We end up with 5 equals negative 16 plus 24 minus 3, which ends up giving us 5 equals negative 16 minus 3, so negative 19. 24 and negative 19 is going to give us 5, so we're good. So we've graphically solved this, giving us these solutions here, and then we've checked to make sure that those are correct by plugging them back into our original equations. Why don't you go ahead and do the same process with the next question. Again, pause this video when you're ready, turn it back on, and we'll take a look and see how you did. Alright, so again, we said we want to get into our y equals format, so I've done that. Once you graph it and check your solutions, you should end up with 0, 3, and negative 2, negative 5. Okay, if you didn't get those, go back to our previous question and walk through those steps we went through for our calculator. Make sure we've done that correctly, and we should come out with this solution. Once again, we can verify this, plug it into our original equation, and make sure that we're all good. So let's go on to our last page. Alright, so we have a word problem here then. The sum of two numbers is 3, and twice the larger number is 36 more than 3 times the smaller number. Find the numbers. Go ahead, try to set up your let statements and our system of equations, and then we'll go ahead and work through this together. So we have multiple ways of doing this. I chose to go with my x equal to the larger number and y equal to our smaller number. So the sum of two numbers is 3. This tells us that if we add these x and y's together, we're going to get 3. And then we see that twice the larger number is 36 more than 3 times the smaller number. Okay, so what does that mean? Well, twice the larger number, so 2 times our larger number, which is x, is 36 more. So if I subtract 36, then we're going to be getting to our smaller number. All right. Not just to our smaller number, but to 3 times that smaller number, meaning I need 3y. Okay, so there we have our system of equations then. Now it's just a matter of plugging these into our calculator and finding our intersection points, finding our solution. Again, we start off by getting into our y equals format. So I'm subtracting x from this first one to get 3 minus x. And then the second one, I'm dividing by 3 to get y equals 2/3 x and negative 12. Go ahead and plug this into your graphing calculator. Again, setting your y1 and y2 to these equations, finding our intersections, and therefore getting our solutions. Okay, so even before graphing, if we had taken a look, we would have noticed that we have different slopes as well as different y-intercepts. So we know we are going to have one solution, and we should have found out that that ended up being 9, negative 6. Okay, so this tells us then, again, this is our x-intercept, this is our y. So our x is our larger number. That works. Our negative 6 is our smaller number. So our larger being 9, our smaller being negative 6. Okay, with these word problems, it's especially helpful to double check. So if we take a look, the sum of two numbers is 3. So if I take 9 and negative 6, that sum is going to be 3. And twice the larger number is 36 more. So if I take 9 times 2, which gives me 18, that number should be 36 more than 3 times the smaller number. So if I take 3 times the smaller number, we get negative 18. So is 18 36 more than negative 18? Well, yes it is. So we know that we do indeed have our numbers 9 and negative 6. Should probably write that out in a little statement. So our numbers are 9 and negative 6. All right, let's do our last question then. The rectangle has to be drawn with perimeter 64 centimeters. If the length is to be 14 centimeters more than the width, determine the area of the rectangle. Go ahead, try to set up what's going on, try to set up your let statements, maybe our system of equations as well, and working through it, hit play when you're ready to come back together. Okay, so again, we could do this different ways. I chose to let x equal my width and let y equal my length. Okay, so if I draw out my rectangle, my width here and my length here. Again, my length should be longer. It says that in our question. So we want to get our system of equations going. A rectangle has to be drawn with a perimeter of 64. Well, what is perimeter? That's adding all our lengths, all our widths together, or same as going 2 times our lengths, so 2y, plus 2 times our widths, so 2x, and that should give us 64. We also know that the length is to be 14 centimeters more than the width, so that means our width plus 14 should give us our length. Okay, there's our system of equations. Again, at this point, it's a matter of getting y by itself, plugging that into our graphing calculator, finding our intersection points, and we should have our lengths and our areas. Okay, so when we go ahead and work that out, we should end up getting a solution of 923. 9 being our smaller number, that being our width, again our x, and our y being 23. Okay, now common mistake, this is our answer, calling it quits here. Notice the question does not ask for our solution, it asks for the area of the rectangle. Last step then is to find that area. We know area equals length times width, 23 times 9, so we get 207 square centimeters. All right, I hope that was helpful. We should be good to go on to our assignment then. Again, do as many questions as you need. This here is the minimum amount before I want you to move on to write the quiz. Good luck, and as always, come see me if you have any questions.